Hello, everyone. My name is Ankush Das, and I'm an applied scientist at Amazon. And I recently graduated from CMU, where I designed this programming language called Nomos, which is a protocol enforcing asset tracking and gas-aware language for smart contracts. Next slide, please. So you may be wondering what exactly do all these terms. Okay. Yeah. So you may be wondering what exactly do all these three terms mean? Well, excellent question. That's exactly what I'll be answering during this session. Next slide, please. And let's begin with protocol enforcement in the context of this auction contract. Now, as you may well know, the auction has two separate phases. First, when the auction is open, when bidders are placing their bids into the auction. Next slide, please. And the second, when the auction is closed, when bidders are collecting their wins out of the auction. So if you implement this auction in the Nomos language, the language will guarantee that bidders can only place bids when the auction is open, and bidders can only collect their wins when the auction is closed. Next slide, please. If a malicious bidder decides to collect when the auction is open, next slide, please, that's a compilation error. Similarly, if a malicious bidder tries to bid when the auction is closed, next slide, please, then that would again be a compilation error. Next slide, please. Next slide. So now let's talk about asset tracking. And observe this again in the context of this auction protocol. Next slide, please. So if a bidder, let's say, places a bid of exactly 2 coins into the auction, and if you implement this auction in the Nomos language, you are guaranteed that if the bidder's balance goes down by 2 coins, next slide, please, then the auction's balance goes up exactly by 2 coins. Next slide, please. If the auction's balance is accidentally increased by 1 coin or 3 coins or anything more or less by the smart contract developer, then again, that would be a compilation error. Next slide, please. And finally, let's talk about gas awareness, again, in the context of this auction protocol. So, and suppose there are these bidders who are placing their bids as well as collecting their wins out of the auction. Now, how would the smart contract developer compute the gas cost of these transactions? Well, in the Nomos language, the smart contract developer doesn't have to. The language will compute the gas cost of transactions for you. Next slide, please. So for example, in this auction, let's say the cost of bidding into the auction is 10 units and the cost of collecting out of the auction is 20 units. Both of these is automatically computed by the language for you. And that's again static. So it's not at runtime. This is all done by the language at compile time. Next slide, please. And so you may be wondering, how are all these amazing guarantees achieved? And the short answer is resource-aware session types. This is a system that I designed during my PhD, and it has 3 major components. One is the session type component, which is a system for enforcing communication protocols in message passing systems. And here in this Nomos language, it's used to enforce protocols of communication between different smart contracts. The second is the linear component of session types. This is used to represent assets, and it prevents their accidental duplication or deletion. And the third component is resource-aware types. This is used to automatically compute the gas cost of different transactions. Another feature that I did not talk about is that smart contracts in Nomos are always guaranteed to be free of any kind of reentrancy attacks. And finally, most importantly, all these guarantees are provided by a formal type safety theorem. So there isn't a runtime monitor, or these are not experimentally validated things. These are all guaranteed by a mathematical theorem that supports the Nomos language. And this language is available open source. You can go on this website. In fact, that's what I'll do right now. So I'll switch over to my screen sharing right now. And here you can see I've already opened up the Nomos website for you. And if you go on the web interface, here you can see that you can write your own transactions. There are some preloaded transactions for you. So for example, here, let's say I want to load a transaction that I just talked about, the auction transaction in this session. And let's say I want to create two accounts. One is for the auction owner, and let's say I create an account with a balance of 10,000. And let's say I also create an account in my name just to place bids into the auction. So again, I create an account, and here on the bottom right, you can see that the accounts are being created. And on the top left, you see the transaction code. So here you can see that there's this auction type where you can see that it has three phases: the running phase when the auction is open, the ended phase when the auction is closed, and terminated when the auction is done. And you can see in each phase what are the operations that are allowed by the auction. So in the running phase, you can place bids. In the ended phase, you can collect. And in the terminated phase, you cannot do anything. So if you go ahead and type check this transaction, here on the bottom right, you can see ready to submit with gas bound of 10. So you can see that the auction contract's gas bound was automatically computed by the language. And now suppose I submit this in the auction owner's account. And so you can see the transaction was posted. You can see on the bottom left that a channel was created. You can look at the session type of the channel and so on. Now suppose I want to place a bid into this auction. So here is the code for placing a bid. And here is when I'm sending the money to the auction. So here I'll show how the asset tracking is observed. So let's say a programmer, for example, forgets to send the money to the auction. And if you type check this, it'll give you a compilation error. Similarly, suppose you place the bid twice, you send this again, and if you type check try to type check that, again, it will be a type error. So it's a compilation error. So now I remove that, and I try to type check this again, and now it's type checking successful, and it's ready to be submitted with a gas bound of 23. So now I can submit it in my own name, and the transaction was posted. You can even see my account balance going down, and even the auction owner's account balance going down. So anytime you submit a transaction, whatever is the gas cost is automatically deducted from your account. And finally, I can do a collect. So here is the code to collect. If I win the auction, then I get the lot. If I lose the auction, then I get my money back. And again, if I try to type check this, it's ready to be submitted with gas bound 24, and I can submit it. And you can see that my account balance has gone down again. So that's basically what I wanted to show you. I encourage you to look at the website and use Nomos for your own transactions and try to simulate them, create your own blockchain. I'm happy to take some questions now. So what is your biggest challenge when developing this language? So the biggest challenge was basically how can you integrate all these three features into one unified language. That's difficult for a variety of reasons. One is and integrate it in a way that the burden on the programmer is as minimal as possible. So what we try to do, for example, gas cost inference and linearity, we embedded it in a way that if the programmer makes a mistake, then we give very precise error messages, which are constructive so that the programmer can correct them in their contract code. So that I would say was the biggest challenge. Any other questions? Another challenge in this work was how can you do inference and type checking, provide all these guarantees in a way that's efficient. So the way it is set up right now is it's all linear time.